Radio telescopes across the globe are pointing toward the same patch of sky, listening for something that has never been detected before. Atlas has just passed through its perihelion, the moment of maximum solar heating that could reveal its true nature. This isn't just any interstellar visitor. Atlas is the third known object from beyond our solar system, but with a minimum diameter of 5 kilometers, it's 1 million times more massive than Oumuamua and 1,000 times larger than 2I Borisov. Scientists are monitoring for specific technological signatures, controlled maneuvers, mini-probe deployments, radio transmissions, artificial lights, or excess heat from possible engines. If it's natural, we might see spectacular fragmentation. If it's artificial, we could witness something unprecedented. The data collected in these next few weeks will determine whether we're alone in the universe or whether something intelligent has been studying us. But here's the challenge. The most crucial moment occurred when we couldn't watch. On October 29, 2025, Atlas reached perihelion, its closest approach to our Sun. This moment should have been the perfect opportunity to witness how intense solar heating affects an interstellar visitor. The problem is that Earth's orbital position placed Atlas directly behind the Sun from our perspective, creating what astronomers call a solar conjunction. Solar conjunctions occur regularly as planets and objects move through their orbits. But having one coincide precisely with an interstellar object's perihelion creates an extraordinary observational challenge. The Sun's brilliant disk completely blocks our view of Atlas during the exact moment when solar radiation would trigger the most dramatic changes to its structure and behavior. At perihelion, Atlas was being heated by 770 watts per square meter of solar radiation. JPL Horizon's data calculated this precise timing with accuracy of just a few minutes, emphasizing how astronomical prediction can be incredibly precise, while observational constraints leave us completely frustrated. Scientists find themselves in the position of conducting a critical experiment with the laboratory door locked. They know something significant is happening just out of sight, but they can't observe the process directly. The intense solar heating at perihelion acts as a natural test that reveals an object's true composition. Natural comets typically respond predictably to this thermal stress. Ice begins sublimating into gas, dust particles stream away from the nucleus, and fragile structures can break apart entirely under the extreme conditions. If Atlas is a natural comet, held together by weak forces, this intense heating may have been fragmenting it at that exact hidden moment, creating an invisible spectacle. An artificial object might behave completely differently. It could deploy smaller probes, execute controlled maneuvers, or begin transmitting signals as internal systems activate in response to the sudden influx of solar energy. These signatures would provide definitive proof of Atlas's artificial nature, but only if we could observe them happening. The Sun creates a wall of electromagnetic interference that blocks most forms of observation. Direct optical telescopes can't penetrate the solar glare to capture images of Atlas's surface changes. Infrared instruments, which detect heat signatures that could reveal internal structure, also become useless when pointed toward the Sun. Even the most powerful space-based observatories find themselves temporarily blinded. Radio telescopes offer the only window through this observational darkness. Radio waves can penetrate some solar interference, allowing astronomers to listen for deliberate transmissions or unusual electromagnetic activity. But radio observations provide limited information compared to the detailed visual and thermal data that optical and infrared telescopes could have captured. This cosmic timing creates what astrophysicist Avi Loeb calls the mystery of the moment. We simply don't know what happened to Atlas during its most critical phase because it was hidden behind our star. The situation resembles trying to understand a chemical reaction by examining only the before and after states without witnessing the transformation itself. What makes this observational challenge even more frustrating is how a simple shift in timing could have provided answers. 6 months could have changed everything we know about Atlas. Here's the opportunity that cosmic geometry stole from us. Radar mapping represents the gold standard for characterizing unknown objects in space. These systems bounce radio waves off a target and analyze the returning signals to create detailed three-dimensional models. The technique reveals internal structure, surface composition, and density measurements that no other observational method can provide. If Atlas had arrived just 6 months earlier or later, Earth would have been positioned to capture it at a distance of only 54 million kilometers. At that range, our most powerful radar systems could have mapped Atlas's entire surface as it completed its 16.2-hour rotation cycle. The rotating object would have presented multiple viewing angles during the mapping window, allowing scientists to construct a complete picture of its shape and structure. This radar interrogation would have provided the kind of definitive data that settles debates about an object's nature. Instead, Atlas's actual closest approach to Earth occurs on December 19, 2025, at a distance of 269 million kilometers. That 5-fold increase in distance makes radar detection completely unfeasible, not just more difficult. The difference is like trying to photograph a coin from across the street versus from 5 blocks away. At the closer distance, you can make out fine details, surface texture, and even read small text. From 5 blocks away, you might barely distinguish the coin as a round object. This distance constraint forces a complete shift in observational strategy. Scientists must rely on passive optical observations that can only capture reflected sunlight from Atlas's surface. Radio telescopes can listen for potential transmissions, but they cannot actively probe the object's structure through radar mapping. The data becomes fragmented and indirect, rather than comprehensive and definitive. The missed radar opportunity represents more than just lost scientific detail. Active radar interrogation allows researchers to ask specific questions about an object's composition and receive clear answers through signal analysis. We lose the ability to directly measure Atlas's size and create three-dimensional images of its shape, which would have provided definitive evidence about its artificial or natural origin. What we lose is the ability to peer inside Atlas and understand its true construction. Radar can penetrate surface layers and reveal internal cavities, dense cores, or hollow sections that might indicate artificial manufacturing. These internal characteristics often provide the clearest evidence of whether an object formed naturally in space or was constructed by intelligent beings. The cosmic timing that placed Atlas at its current distance during its closest approach essentially locked the door on our most powerful investigative tool. We're left assembling Atlas's identity from fragments of indirect evidence rather than conducting the thorough examination that radar mapping would have provided. But Atlas still faces one final test that could reveal its deepest secrets. Solar heating at this distance creates a natural laboratory that exposes an object's true composition and construction. When Atlas reached perihelion, it faced intense radiation and gravitational forces that penetrate surface layers, vaporize materials, and can cause structural failure in objects lacking internal strength to withstand thermal expansion. Natural comets follow predictable patterns under this solar stress test. Ice sublimates directly from solid to gas, creating pressure that forces material away from the nucleus. Dust particles get caught in gas streams and form characteristic tails pointing away from the sun. Fragile structures break apart as different materials expand at different rates, creating internal tensions that exceed structural limits. But Atlas has already shown behavior that defies these natural patterns. During July and August 2025, Atlas exhibited a jet directed toward the Sun. Anti-tail behavior never observed in natural comets. This violates the fundamental physical law that comet tails point away from the Sun due to radiation pressure. No natural process can explain material streaming toward our star against the force of solar wind. The composition of Atlas's gaseous plume reveals equally anomalous characteristics. Analysis shows much more nickel than iron, similar to artificially produced industrial alloys rather than natural space materials. Atlas contains only 4% water by mass, contrasting dramatically with typical comets that are 80 to 90% water ice. These ratios don't match any known natural formation process in our solar system or interstellar space. Atlas also showed extreme negative polarization, unprecedented in all known comets. This optical signature suggests surface properties completely different from any known cometary material. The polarization patterns indicate a surface composition that reflects light in ways that natural ice, rock, and dust simply cannot produce. Even Atlas's trajectory raises questions about natural origins. The object's path aligns to just 5 degrees from the ecliptic plane, a probability of only 0.2% for an object from deep interstellar space where direction should be random. This precise alignment suggests it was deliberately directed to follow our solar system's orbital rules rather than arriving from a random direction in 3-dimensional space. Scientists are monitoring for 3 key signatures that will determine Atlas's nature. Fragmentation patterns show whether the object breaks apart randomly, like natural materials, or maintains structural integrity, suggesting artificial construction. Directional emissions could indicate controlled release of materials rather than uniform outgassing from solar heating. Any deviation from predictable orbital mechanics would suggest active propulsion systems. Radio telescopes worldwide coordinate to catch deliberate transmissions as Atlas moves away from solar interference. Electromagnetic noise from our Sun decreases as Atlas travels further from perihelion, creating a window where artificial signals could become detectable above background radiation. Congresswoman Ana Paulina Luna is actively working to have high-resolution images from October 2nd, 2025 released to the scientific community, showing governmental involvement in the Atlas investigation. The data collected during these critical weeks will provide the evidence needed to determine Atlas's true nature. What emerges from this analysis defies natural explanation. When you multiply all the small probabilities of Atlas's anomalous characteristics, the anti-tail behavior, the unusual composition, the extreme polarization, the precise trajectory alignment, mean the cumulative chance of natural occurrence drops below 1 part in 10 quadrillion. These aren't just unusual features, they represent a mathematical impossibility for coincidence. Astrophysicist Avi Loeb has classified Atlas with a score of 4 on the Loeb scale, where 0 is definitely natural and 10 is definitely technological. This scientific assessment places Atlas firmly in the category demanding serious consideration as potentially artificial. If Atlas proves technological, its creators demonstrate capabilities that go far beyond our current technologies. The implications for humanity's understanding of our place in the universe would be profound.